This is the guts of a Ryobi P118 battery charger for their OnePlus system of 18-volt tools. And the thing was held together with these stupid, annoying, tamper-resistant torque screws. They're T15s, but they aren't very well made in the sense that tamper-resistant stud isn't very tall, so I was able to get a bit of purchase on it with this crappy Harbor Freight torque screwdriver, although it kind of rounded off the ends of it, and I had to use it, and I had to regrind this a couple of times with my mini bench grinder. But was able to open the thing. But I'm going to be getting some better tamper-resistant torque screwdrivers from Granger or McMaster-Carr or something next order. I have to place with either of them. And it's just a typical injection molded plastic case. Acrylonitrile butadiene styrene. One interesting thing is that there's one of these little memory metal anti-theft things, or no, it's amorphous metal thingamajigs built right into the case, which is somewhat unusual. Let me set that in the packaging, unless that's for inventory control or something. Someone that would use one of these. This is the underside of the PC board. It's a hybrid fiberglass and paper laminate material, which isn't quite as bad as the pure paper laminate stuff, but pure something like FR4, which is the standard stuff nowadays, would be a bit better. Bit of flux sponge, but really good isolation barrier between the main side and the battery charger side, which of course has exposed metal that the user could end up touching. These are the two power connections for charging the battery, and this is one for one of the thermal sensors. The lithium-ion batteries, which are one of the things that this can charge, although this can also charge the older NiCads, is that there's two separate, what are marked as thermal things. That's fairly typical in a lot of these higher quality drill batteries, is that you'll have a power connections and a third one for either a thermistor or thermal switch, and I've seen some of the older Makita stick batteries that I've rebuilt have 4 contacts, one thermal switch and one thermistor for temperature monitoring of the cells in the battery. And I have another charger which I'm going to do a guts video on once I get another Torx thing that can fit it. And that has 2 contacts. This is the P117, that's the one I'm speaking of. Is that it has them marked as T2 and T1, as well as one for another contact that isn't fitted, or that isn't installed or done anything with, that's marked as plain T. Now, when I first got the system, I figured that would be some kind of, that's this contact on the thing. I originally figured that would be for some kind of a serial communications protocol for the charger communicating with the charge or cell management integrated circuit in the lithium, because all these multi-cell lithium batteries need to have that for cell balancing, because otherwise you could inadvertently overcharge one of the cells and then the thing would blow up, which would be bad. But looking at that might be for a secondary thermal switch, or because on these intelligent batteries that do have that, they're usually marked as C for communications. Now, it could also be that is just some kind of a level thing where this charger drives that rail either high or low, and then the charge controller IC and the battery responds again by either keeping it that level or driving it to some other level. So a really simple, very rudimentary bidirectional serial protocol, but considering that this only really needs to say, yes, I'm fully charged, no, I'm not fully charged, you can get away with that, and it's actually fairly easy to implement. But anyways, on the other side of the board, there's that, which is presumably a date code. There's that, which is a metal oxide varistor, input fuse, loads of this scholastic goo just for mechanical retention of components, which is a good thing to see in something like this that would be jostled around and whatnot in use. A PTC for inrush protection so that you don't get a spark when you plug the thing in from that cap charging. Bridged over space for a common mode choke, but there's already one there. That might just be as a I don't know, an LCL filter or something, which they didn't really need to implement. Rat sprayage of 1N4000, 14007, so fairly typical, 1000 volt 1 ampere rectifiers. Input cap, there's a space for another one which isn't fitted. I don't looks like they dual footprinted it for 2 different lead spacings. Main switching device for the switching power supply. Another cap. Opto for controlling the FET. It's probably going to be a FET. A couple of sense resistors. RS1, those are probably current sense resistors. One interesting thing about this is that there's lots of things like these electrolytics are marked with EC1 for electrolytic capacitor. Like those 2 caps, which are for QRM suppression. Those are CY2, stating that those are Y caps, which is a good thing to see because Y caps are what are rated for connecting mains directly to exposed metal that the user could touch that isn't explicitly grounded. And sometimes in lots of Chinese garbage, when those are even used at all, they're usually not proper Y caps. That's just a safety thing. Those are high reliability capacitors. Another electrolytic for the output side. This header marked 5 volts ground, clock, and data. That's just, I'm guessing that's for in-circuit serial programming of the microcontroller in this. Bunch of what are probably 1% resistors. In this application, probably legit 1% resistors for things like dividers or something. And that's just a current sensing shunt for monitoring battery charge current. And on the other side, right by the ICSP thing, which was right there, there's that, so that's just going to be the microcontroller controlling it. It's a ASOV or ABOV, I don't recognize it, ADC2 something 11, so don't know exactly what that is. ADC is usually just suggestive of a microcontroller, but or an analog digital converter, but that could be, well, it's probably some highly obscure ADC2 made in South Korea, so it wouldn't be one of the really horrible Chinese ones. Assuming that's not counterfeited. Looks like a bit of a adhesive sticking out the side, so this whole board was probably flow soldered. And which means that all these components are individually glued down. Yeah, you can see like on that MELF package diode, I can see adhesive, so this was flow soldered. Which means that you don't have to have things like screen printing the, or silk screening the solder paste and all that complicated guff, but it also means that you've got limits as far as component spacings, because otherwise if you flow solder a board with too tight a component spacing, you can get solder bridging, which would be bad. So then there's this device. It's a AS324M. Oh, that's probably that's probably a there's an A mark, so that's probably a an in-house variant of an LM324 by some obscure Chinese manufacturer. That's probably a bunch of caps, so that might be being used as a combination buffer and filter, because the 2 Kelvin connections from the sense resistor, which is there and there, go over to this. There's a bunch of really fluid traces on this. Might be probably some really high-end CAD software that can replicate things like tape boards, because at first glance this looks a lot like a tape board. Almost, who knows, maybe they're still doing that for non-critical power supply stuff like this, but yeah, anyways. And then there's that. That's probably just probably a FET of some sort. And 301. Okay, 100 ohm. No idea what that's for. Oh, that's. Oh wait, that's probably more current sensing, because that's the transformer. That's just switching power supply guff. And that. Let's see, what are the traces for that one doing? It's a fuse. Okay, that's just a current control FET for the charging the battery, and then there's a fuse right across those two terminals. So overall, looks like a fairly typical recent design power supply for or battery charger for lithium-ion stuff, and nothing screamingly horrible. And then there's a pair of idiot lights which just shine through two translucent holes in the label. Yeah. Nothing really screamingly horrible in this one. Or nothing really horrible, just fairly typical for what it is.